Hello, my name is Matthew Suarez, and I'll be going over my senior project, which is about predictive data analytics at campus dining. So my senior project is working with campus dining to create a forecasting system capable of making accurate daily menu item forecasts specifically for their PICOS menu items. Here's the official problem statement. And basically it outlines their issue is the costs associated with excess stocking of menu items that they then have to throw out. So everything they bring out to use for a day, for example, if it doesn't get used, a lot of it they have to throw out. So a more accurate forecasting system will help them cut costs from knowing better about how much they need to bring out for a day. So the project basically outlined in 4 parts. The first part is going to be creating the forecast algorithm itself, and then also the UI to display that forecast to the people who are going to be using this. And then also attached is the economic justification as well as the accuracy tests, comparing how accurate it is to live data. So here's a first example of some data that I got. This is specifically just the month of January, and it outlines kind of each week here, as each rise and fall is associated with each week. Each dip is Saturday. I don't just have 1 month, however. I have more than just January. He sent me back all the way back to October. So I have almost, a full year or full academic year's worth of data to work with. So one of the first things I did is decompose the data, or excuse me, data, and here's the curve, what it looks like here. And this is the seasonal component, and here's the trend line, and here's the difference between those two. So using that, I can develop what's called an ARIMA model. And an ARIMA model, that stands for the Auto-Regressive Integrated Moving Average, by the way. It's quite a complex method of forecasting, which is primarily used when there's a lot of seasonality involved with the data, which with mine there most definitely is. I also used the naive approach, just as a baseline to compare. The naive approach is usually pretty bad, and as well as a seasonal naive approach as well, which in so doing both of those, or 3 of these, we can compare the accuracy from various different measures to each other, and the primary measure is the MAPE, or the measuring of absolute percent error between them, and usually the lowest one is the best. These are all considered pretty good, though, surprisingly, as generally a MAPE lower than 20 is good and lower than 10 is excellent. So as we can see, the ARIMA model is very good, but the seasonal naive model is actually the best. And the reason being is that the weekdays, or the primary seasonality of the data is the weekday, more than anything else. And so while the ARIMA takes into account a lot of the other seasonalities, they actually don't affect the data as much as just the plain old recency. So using that, I've created this UI, which, as you can see, they can just select the item and the forecast date, and out will pop up how much of each ingredient they'll need. And then as for the classes used, this kind of outlines it. Basically, mainly IME 410, though. And yeah, that's about it. Thanks for watching.